Recording in progress. So let's start with a very easy question. You probably know it already. What is your name and what is your current position?
My name is Emma Alexander. I'm an assistant professor at Northwestern University.
Very, very nice. And you are also a co-organizer of a very nice workshop at the upcoming CVPR 2022, which is CCD.
Yes, the Computational Cameras and Displays Workshop.
Very nice.
So a computational camera is a camera where the optics and the algorithm are co-designed to make scene information available. So maybe you're moving some of your computation into the optics to use the physics of light to pre-process your data and save on computational efficiency. Or maybe you're using a lot of computation in order to exceed the native limits of your optical system. And so this unlocks a really big area of potential in both cameras and displays, where instead of using the standard data sets and the standard looking photographic and video data, we alter the optical pipeline to create whole new kinds of data to access and display information.
So what is the story?
Certainly. Yeah, there's a lot of new work that comes out every single year. Unfortunately, I don't have the titles from our invited speakers yet, so I don't know what we're going to be covering. But there's lots of space to explore in displays and in cameras. Our standard cameras are very simple. It's basically a lens and a sensor. There's tons of new designs. There's new technologies all the time, new kinds of optics, new kinds of sensors, new kinds of displays. But even within the components that we know of, right? Just arranging lenses and filters in new ways, pairing them with new algorithms. There's so much space that has not been explored. So I think it's one where, you know, every advance that happens in mainstream computer vision just gets sort of multiplied and exponentially expanded in terms of the potential once you let, you know, every single component change sort of combinatorially. So I think we're never going to run out of new computational cameras and displays. I think what makes CCD special is that when you break out of the mold of what a camera or a display is, you can sort of bring back the magic of science and problem solving. It's going to be a really creative workshop. You're going to see and think about things in new ways. I always learn not just new facts or new techniques, but like whole new perspectives on the field by finding out about these really creative, innovative ways that people are thinking about things that the rest of the field kind of takes for granted. Yeah, I think what we wanted to do was to really showcase the diversity of the field. So we wanted to have people at various points of their careers, and we wanted to cover a wide swath of topics. So we wanted everyone to be presenting ideas that were going to, you know, not overlap too much with what anyone else was doing, you know, sort of cover a wide range geographically. This is sort of a workshop that that showcases unusual and new and different perspectives. So it was really about getting a widespread of amazing work that was being done, but in a lot of different places, in a lot of different ways, by people who are pretty different from each other. Yeah, that is such a good and interesting question. You know, everyone we invited was able to make it, which was really fortunate. Oh man, you know, I think it's maybe, so like sort of the big names, you know, we've had no problem drawing them in, but I think the fear as an organizer is always that we're going to miss new sort of creative thinkers on the edge of things, people who aren't as well connected. And so, you know, I guess I would sort of hope that maybe we could get like a poster submission from a grad student we've never heard of so that next year we can invite them. I think that's my main concern. Well, yeah, they should definitely come to mind. That's tip number one. No, I think CVPR is sort of this overwhelming circus, and what you think you're going to be interested in versus what actually catches your eye and your interest, it's always pretty unpredictable. So I would just say, like, be open, explore widely, and you know, don't be shy. Like, these folks have missed out on a lot of years of getting to know each other. In normal circumstances, they would all already be friends. So they should make sure to make friends with each other and know that everyone who's a little more established in the field is, you know, looking out for them and missing them, and that they shouldn't be shy. Just talk to a lot of people. Yeah. I think there's going to be tons of really exciting stuff. We're seeing new kinds of optics and sensors being developed all the time. We're seeing sort of a principled incorporation of the tools from machine learning and the sort of fundamentals of physics and mathematical modeling. We're making a lot of progress on both of those fronts, but I think the real missing piece, and one that this workshop is actively addressing, is how you put them together in a principled way so that you can really take advantage of both. And I'm so excited to see where that goes. I think I would just say that, you know, anyone who wants to combine the engineering tools that are really highlighted at CVPR along with like a deeper scientific understanding of imaging, this is probably the workshop they want to come to.
That is very nice.